The slope-intercept form of a line is when the equation of a line is written in this standard form. First of all, it's solved for y. Then we're looking for a number in front of x plus or minus another number. These two, the m and the b, are very important values and they're very meaningful in the equation of the line. M is the slope of the line. B is the y-intercept of the line, where the line crosses the y-axis. Using these two pieces, the slope and the y-intercept, I can graph the line. Let's look at a few examples of equations written in slope-intercept form. Y equals 2x plus 1. Remember, the number in front of x is always the slope, so in this example, the slope is 2. The y-intercept is the number being added or subtracted at the end, so the y-intercept in this one is positive 1. If we look to the next example, the slope is 1/2, and the y-intercept is negative 3. This one's a little trickier. What is the number that's in front of x? 1. Okay, if there's not a number there, think of it as 1 times x. What is the number being added or subtracted at the end? Nothing, so the y-intercept here is 0. This last one, if I'm looking for the slope, what's the number that's in front of x? Well, there isn't an x here. I could imagine that there's one there. For example, like 0 plus 0x. That would make the slope here 0. What's the y-intercept? Well, that's the number being added or subtracted to the x term. So the y-intercept here would be positive 4. I want to graph the line y equals negative x plus 5. To start, I'm going to pick the point that I know this line goes through. I know that the y-intercept is 5. And the y-intercept is where the graph crosses the y-axis. So I will go on the y-axis and put one point at 5. I also know that the slope here is negative 1. If I make the slope a fraction, I can use rise over run to find another point. So from this point, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. All of these are points on this line. When I connect them with a solid line, there's the graph of the line. Let's graph another equation. Start by finding the y-intercept. The y-intercept of this one is 4. So put 4 on your y-axis. That's your starting point. The slope of this line is 2/3. So this tells me that I'm going to rise up 2 and over 3 to find the next point. Up 2 over 3. Up 2 over 3. Or I could go down 2 and backwards 3. But all of these points follow that line. And there's the graph of the line. I want to graph 3x minus 5y equals 10 using slope and y-intercept. The problem with this one is that it's not written in slope-intercept form. I must rearrange it. So in order to do that, I need to solve the equation for y. So I'm going to start by subtracting 3x, and then dividing everything through by negative 5. So y equals 10 divided by negative 5 is negative 2. Negative 3 divided by negative 5 is a positive 3/5 x. Negative divided by a negative is a positive number. This is what I want to graph with, because I can see here that the y-intercept is negative 2 and the slope is 3/5. Now all I have to do is graph. The y-intercept is negative 2, that's my starting point. From this point I'm going to go up 3 over 1, 2, 3, 4, 5. Up 3 over 5. Those 2 points are on my line. Connect them, and I have my graph. Parallel lines have the same slope. So to show that these two equations are parallel, I need to show that they have the same slope. In order to find their slope, I need to solve both for y. So I'm going to start on the left here and subtract 2x and divide everything through by negative 3. Y equals 7 divided by negative 3 is negative 7/3. Negative 2 divided by negative 3 is a positive 2/3 x. So the slope here is 2/3. This line, I'm going to start by adding 2x. So 3y equals 4 plus 2x. And now I'm dividing everything through by 3. This equation, y equals 4/3 plus 2/3 x. What's the slope in the equation? Positive 2/3. The slopes are the same, so the lines are parallel.